Hello viewers, in this video we will see the solution to week 3 assignment 3 for the course analog communication. First question, the energy spectral density of a signal can be obtained by a Fourier transform by taking the Fourier transform of. The answer for this question is option C. Option C, Fourier transform of autocorrelation function of the signal. Option C, Fourier transform of the autocorrelation function of the signal. Option C. Second one, the area under the power spectral density curve of a signal represents. So it is option B, total power of the signal. Total power of the signal. Option B. Third one, which of the following is a property of energy spectral density for a real valued signal? So the answer is even. Option B, even symmetric function. Even. Option B. Option B, even function. How can a power spectral density of a non-periodic signal can be calculated? Option B, by truncating. Option B, by truncating. Fifth one, the energy spectral density of product of two signals is always equal to the product of their individual energy spectral densities. False. A random binary signal XT transmit a binary 1 by a non-negative rectangular pulse of width dB by 2 and amplitude 1 and a binary 0 by no pulse. The digits 1 and 0 are equally likely and occur randomly. The autocorrelation function Rx tau is answer is option C. Option C. So 1 by 4 delta 2 tau TB plus 1 by 8 summation except for 0 delta 2 into bracket tau minus n TB by TB. Option C. Seventh one, for a deterministic signal XT with finite energy, which of the following is true about its energy spectral density? Answer is option C, non-negative and integrable. Option C, ESD is non-negative and integrable over all frequencies. Eighth one, if the power spectral density of a signal is known to be x of f, what is the power spectral density of the signal modulated by the carrier frequency fc? The answer is option D. The correct answer is 1 by 4 shifted version shifted by left, power spectral density shifted by left and right shifted left and right by fc. Answer is shifted to fc. Option D. Null bandwidth of a signal is defined to be the least frequency f naught such where h of f is the energy spectral density of that signal. Find f naught for rectangular function. So the answer for this is the sinc function, and this is the first null, and it is at f equal to 1 by capital T. So which T is the duration of the rectangular pulse. So the answer is option A, 1 by T. Next one, let x of t equal to sinc pi t capital T and y of t equal to derivative of x of t with respect to t. Find the energy spectral density S of f of the y of t. So the answer for this is, so we know the relationship between the sinc function and the rectangular function. A sinc 2wt equal to a 2w rectangular function f by 2w. If I substitute 2w equal to t and a equal to 1, so what I get is 4 pi square, and of course the differentiation of any function in the frequency domain becomes multiplication of the factor j 2 pi f to the spectrum of the given signal. This is the spectrum of the given signal, that is the sinc function, and what we get is 4 pi square f square by t square rectangular function square f. Option D, f by tb. Okay, so that is option last, option D. Thank you.